All right, so this is part 2 of our performance review. The first 3 examples are going to be finding the inverse of the function. So the first thing that you want to do is swap out your x's and y's. So the x is going to be on the left-hand side and the y is going to go under your radical. And now this is when you start working with your inverses. You're going to divide the 4 on both sides so that you're trying to work to get that y by itself. You're solving for y right now. This is going to leave you with x divided by 4 is equal to the cube root of y. Well, again, we're trying to get y by itself, so the inverse of a cube root is to cube. What I do to one side, I do to both. And the purpose of doing that, again, is to get rid of that. And I'm just going to go ahead and rewrite that y as the inverse of f of x, or f inverse of x, however you want to say it, is equal to the quantity of x divided by 4, all raised to the third power. That's the inverse for the first one. The second one, we're doing the same thing. We're going to start off by swapping your x's and y's. So x is equal to 1/3 y plus 7. Get rid of the constant by taking the inverse. That means I'm going to subtract 7. That will cause it to be 0. X minus 7 is equal to 1/3y, 1/3 y. And in order to get rid of a fraction, you would multiply both sides by the denominator or the reciprocal, which is, the reciprocal is 3/1. But since it's a 1 in the denominator, we will just multiply by 3. On the left-hand side, you have an expression. So the entire expression has to be multiplied. So that results in 3x minus 21, because 3 times x is 3x, and then 3 times -7 is -21, is equal to y. And I'm going to rewrite it as the inverse of f of x. And then I don't have to factor, just leave it as is, 3x minus 21. That's the answer for that one. So we're doing inverses, but I'm just showing you different types. So this last inverse that we're going to do is when you have a binomial squared. So again, first step, switch out your x's and your y's. And then you're trying to take everything from the right-hand side and move it to the left-hand side, which requires you to use the inverse. So that's going to make it become 0 so that we can solve for y. Over here, I have y minus 5 in parentheses, all raised to the second power, and the inverse of a square is the square root. So to take the square root of one side, I have to end up doing it on the other side as well. The whole purpose is to get rid of that radical, so I can just bring y down by itself, or y minus 5 in this case. So x minus 2 is under a radical, and then I have y minus 5. And to get y by itself, I have to take the inverse of -5, which is +5. However, on the left-hand side, I see that that -2 is under a radical, so I cannot try to combine those. So rewriting my final answer, the inverse of f of x is equal to the square root of x minus 2, and out to the side is a +5. You cannot combine those. One is under the radical and the other is not. All right, so the next section will be graphing the function and then finding the inverse function and graphing it. So the first thing that you want to do is you want to identify certain points. So I'm going to, if I'm dealing with, in this case, an exponential function, and I know it's an exponential function because there's an exponent there. What I would want to do is set that entire exponent equal to, let me set this down here, 0 in one instance. And then I want to also set it equal to 1 in the other instance. Now with the exponential function, I already should know that whatever is my constant is, that's going to be my horizontal asymptote. My horizontal asymptote is shown as y equals, and then that constant. So we already know that part. All right, so let's go back over to x plus 4 equals 0. And what I'm going to do is I'm going to subtract 4 on both sides. That's going to result in x equals -4. So I'm going to take that information, and that's what's going in my table. I'm going to do the other one as well. So -4, -4, and x over here is -3. Let's just be consistent. -4. All right, and so now I take that information that I just put in my table and I substitute it in. When I substitute it in, it's going to give me some answers for my y value, not answers. It's going to give me the output. All right, so my output for -4, if I put -4 in my exponent, it's going to be 2 to the 0 power, which is really 1. 1 minus 3 is -2. And then for -3, if I put -3, it's going to be 2 to the first power, which is 2. And then 2 minus 3 is -1. Now I can also go ahead and try to look for my y-intercept and my x-intercept. I don't have to, but just in case your teacher asks you to do that, y-intercept means your x has to be 0. X-intercept means your y has to be 0. All right, so what I would do is go back to my original function and I would substitute accordingly. So let's move over and get some space here. If I'm trying to solve for my x-intercept, I'm going to go ahead and put the 0 in for y. Let's change colors here. 0 equals 2, and then I keep my x because that's what I'm trying to solve for. This is my this is my x-intercept I'm looking for. So let's just keep track of that. This is my x-intercept. And I'm going to add 3 on both sides because I'm trying to get down to just my x on one side. I have 3 is equal to 2 to the x plus 4. And now at this point, I want to rewrite this as a log. So I'm going to have log base 2 of 3 is equal to x plus 4, but x again is still not by itself, so I'm going to have to subtract 4 on both sides. I cannot combine that 4 and -4 and 3 because the 3 is attached to my log. This is all one item. Okay, so I'm going to just switch this variable on the left-hand side. You don't have to do that. I just do that. Don't know why I do it, but I just do. And then subtract 4 from that. Now, I would actually need to see what this is as a decimal. So if I put it in my calculator, it's going to give me -2.4. So that is what's going in my table for my x-intercept. -2.4 is my x when y is 0. And now if I wanted to do the opposite and I wanted to do my y-intercept, so for the y-intercept, I would replace my x with 0. So let's keep track again, y-intercept. And this becomes y is equal to 2 to the 4th power minus 3. Y is equal to, well, 2 to the 4th power is 2 times 2 times 2 times 2, which is 16. 16 minus 3 is 13. So my y-intercept is going to be 0 for x and 13 for y. That's enough information for me to go ahead and graph, so that's what I'm going to do. I am going to look at my horizontal asymptote, which is -3, and it says y. So where y is equal to -3, that's where I'm going to actually draw my horizontal asymptote. 1, 1, 2, 3, so that's about right here. And it's horizontal, which means it's left and right. And now I can use my other points in my table, which are -4 and -2. So 1, 2, 3, 4, 1, 2. There's a point here, -3, -1. 0 and 13 is going to be way off my graph. -2.4 and 0, so somewhere in here. And now if I connect those, it's going to be an exponential graph that's going towards that 13 for my y-intercept. And that's what the graph looks like. So now I'm asked to also find the domain, range, and asymptote. If I were to take my pencil or my pen and I were to go left and right, I will notice I don't have any restrictions. So for my domain, and it will always be this way when there's an exponential function, my domain is going to be negative infinity to positive infinity. It always goes from left to right when you're reading your graph. My range, however, if I were to take my pencil or my pen or finger, and I start from my asymptote, I always go bottom to top, excuse me. How far can I go and where do I have to stop? So I go from bottom to top, and my range again is, if I'm looking at my asymptote, it's -3. I cannot go below -3. So -3, however, I can go all the way up to infinity. So that is my, excuse my infinity signs. I don't know what's going on with them. Okay, that is my range. My asymptote, we already said it was going to be a horizontal asymptote. And the way you write it is it's listed as y equals -3. So make sure you don't just put -3. It's y equals -3. All right, so that was that one, but the directions asked me to then find the inverse function and graph it. So to save time, I already did the inverse for you because we were just doing that in the first 3 examples. So this is my new function, and you will see that it is now a log. So what I'm going to do, let me just move over this way so I can have some space here. For my inverse function, what I need to do is take my, this time I'm going to take what's in the parentheses and I'm going to set it equal to 0. So the reason I'm setting this equal to 0 is different from the exponential function. This is going to be my vertical asymptote. So x is going to equal -3. Now, a few minutes ago, we did 0 and 1. When you're talking the log function, well, actually, this is what I'm talking about. That when you're talking a log function, and this is what I was just working with a few minutes ago, you want to not only set it equal to 0, which does not go in your table, but you also want to set the x plus 3, the part that's in the parentheses, equal to 1. And you also want to set it equal to whatever your base is. So my base in this instance is 2. So I'm going to set it equal to 2. Solve for x. So I'm going to subtract 3 on both sides. In one instance, x is equal to -4. And in the other instance, x is equal to -1. So I'm going to go over here. And this is what's going in my table, -4 and -1. -4 and -1. Now, what you can do, the easiest thing to do is actually just go back to your original table and then just swap it. You already have negative, what did I say? Negative, I said this wrong, no wonder. Okay, that should be -2. That will matter. And you see, I noticed that because when I go back to my original table, I have a -1 and a -2 in my y value. All I have to do is just swap it. So my new y value is going to be -4 and -3. So that's what I'm going to do. For -2, it is -4. And then for -1, I said -3. And if I just wanted to, I can copy the rest of the table as well, this portion right here, and just switch. You have to switch it around though. So it's going to be 13, 0, and 0, -2.4. So inverses, the only thing you have to do is swap your x's and y's. So you really didn't even have to do this part over here. I just did it for those people who need to understand if your original function was a log, then what you would have to do is not only set it equal to 1, but you have to set it equal to the base. Okay? So let's plot the points now. We have, oh, did we find our, yes, we did. So our vertical asymptote is where x is -3. So that is going to be 1, 2, 3. Vertical this time means up and down. And it's crossing our x-axis. And then what else do we have? We have the points -2, -4. So -2, 1, 2, 3, 4. We also have -1, -3. 13 and 0 is way over on the x-axis. And then we have 0 and negative 2.4 somewhere in there. So if we connect our graph, like I said, it's going all the way over to that 13 and 0. This is what your inverse looks like. That's what a log graph would look like. So now if I'm trying to find my domain, this time if I take my pencil and I see, or my pen, where does this graph start or stop? I see my asymptote is right here and it's going towards the right, which means I could probably draw that a little further down so you can see that it gets real close to it. There we go. All right, so I know I'm going I can't go before the point -3. So for my domain, I'm going to have -3, but I can go all the way to positive infinity. And for my range, this time again, if I'm starting from bottom to top, there's no restriction. So I can go on forever, negative infinity to positive infinity. My asymptote, we already said, it's a vertical asymptote this time, and it is x is equal to -3. Now, if I paid attention, I would see that my domain and range swapped from my original. So a few minutes ago, my domain was negative infinity to positive infinity, but now my range is that. And then I see for my domain, for my inverse, it's -3 to positive infinity. However, it was my range for my original one, -3 and to positive infinity. And then I see my asymptote just changes from y to x, but it's still the same number. Okay. And then the last 3 examples will be solving the equation. So you have to remember the properties whenever you see 2 logs separated by an operation. So in this case, the operation is a plus sign. So that's telling you that you're going to actually multiply those values. So you're going to take 13x and you're going to multiply it times 9, set it equal to 3. And you can just go ahead and change it to exponential form, which is what I'm doing here. This is now 2 raised to the 3rd power is equal to, and then 13x times 9 is 117x. I'm just multiplying the 13 times 7, and then the x is after it. Divide both sides by 117. So x is equal to, well, 2 to the 3rd power is 2 times 2 times 2, which is 8, all over 117. Okay, so when we're solving, what we want to do is we want to double check our work. So that is what I did. I put it in and I meant to show you guys the graph. I'll go back and do that in a minute. So I put it in the calculator for you already. I checked my work. I substituted that 8 over 117, and it told me that the answer should equal 3, which we already know because that's what the original problem said that it would equal. So I know that that is correct. Okay, that's my check. It should equal that 3. For the next one, we're going to take the same, we're doing the same thing. The only difference is we have a subtraction sign. So let's go ahead and divide this time. Log, take the values, 2x divided by 3, set it equal to 4. You don't see it, but it is there. There's a base 10 there. So now you can still rewrite this in exponential form. You just have to keep up with knowing that if there's a log there without a base, it's automatically 10. So 10 raised to the 4th power is equal to 2x divided by 3. Me personally, when I see a fraction that's set equal to a whole number, I will just make both a fraction. And now I will cross multiply. So that is 2x is equal to, well, 10 to the 4th power is going to have 4 zeros after it, multiplied times 3, which is 30,000. I have to divide both sides by 2. And so therefore, x ends up being 15,000. And again, I would take this information and I would put it in the calculator. And I will see that if I were to substitute that 15,000 in, it does end up equaling 4, which is what it was supposed to equal. Okay. And then the last one. This time you can do this 2 ways, but I'm going to rewrite the basis. So 3 raised to the 5x minus 2 is equal to, and I can change that 9 to 3 raised to the second power, but there's a 4 there already. So I'm going to have to multiply that 2 times 4. And the reason I did that is because now I can just go ahead and get rid of those bases and bring down the 5x minus 2 and multiply 2 times 4, which is 8. And now I'm going to add 2 to both sides. And the answer will simplify 5x is equal to 10. And now I'm going to divide both sides by 5. And my final answer is x is equal to 10 divided by 5, which is 2. Double checking my work because again, I am solving. If I double check my work, then I see once I put that information in, on one side is going to equal 6,061. And then if I put in 9 to the 4th power, it also equals that 6,561. So I know I am on the right track. Now, what I want to do is go back to my graph because I meant to show you what my table would look like in a calculator and whether or not my graphs are correct. Okay, so I'm going to go to y equals, and I've already put in my original and I also put in my inverse. If I go to second table or second graph, the first one that's in blue is my table, which is shown here. I have -4, -2, I have -3, -1. And if I were to go to, well, 0 and 13, of course, the -2.4 won't be on there on the X side. But if I go down to my table for my inverse, it should swap. And this time it's in the red. So if you look at -2 and then go to the red, you'll see -4. Go back to the first column, which is in black, -1. Go to the red, it's -3. And I don't have 13. I could go all the way down, but I'm not. And for 0, you can see on the Y column the -2.4, and it just gives more decimals, 1, 5. And if I wanted to see what both graphs look like together, if I hit graph, that's what it looks like. So the blue one represents the original. Let's just go back to that, the original one. And then the red one represents the inverse. So we did pretty good, right? Okay, so I hope that helps someone. And I would like for you guys, if you haven't already, to please like and subscribe. And if you have any questions, make sure that you ask me. Go ahead and put a comment down there or ask in class. Have a good one.